Okay. Sorry, I just bear with me. So just to review, you have your periodic table. You have the S block on the left side. Those are mostly metals. You have the D block in the middle, which we're going to talk about at another point in time. You have the P block on the right-hand side, which is mostly nonmetals. And then we also have the charges. The first column is a +1. The second column is a +2. We skip the transition metals. The 13th column is a +3. The 15th column is a -3. The 16th column is a -2, and the 17th column is a -1. Sorry, I forgot to start the video. Now, when we name compounds, there are some exceptions. So, for example, cadmium is a transition metal. It always has a charge of +2. Zinc is a transition metal. It always has a charge of +2. Silver is a transition metal. It always has a charge of +1. And aluminum is not a transition metal, but it's a P block metal, and it has a charge of +3. The reason why that's important is because most of the transition elements, transition metals, have more than one charge. Like iron will be a +3 and a +2, and gold can be a +1 and a +3. So we try to keep them separated, the ones that don't do that separated. Now, when we go ahead and name ionic compounds, and we're going to deal with ionic compounds specifically, thank you for bearing with me, those of you that were listening. When we name ionic compounds specifically today, we are going to follow some very simple rules. We're going to avoid talking about covalent compounds today, in large part because covalent gets its own unit later on. So the first rule says we name the cation as it's found on the periodic table. And I want to review that a cation is a positive ion. Most cations are metals, and cations tend to lose electrons. And we write the name of the cation, we simply write the name off the periodic table. So like calcium would be the calcium ion. Very simple. The anion is the negative ion. It's mostly nonmetals. These tend to gain electrons. And when we write the name, so we write the name off of the periodic table, but we change the ending to IDE. So if we were to write something like fluorine, would become fluoride. So chlorine becomes chloride, or nitrogen becomes nitride, or oxygen becomes oxide, or sulfur becomes sulfide. Phosphorus becomes phosphoride, something along those lines. So let's practice this, because this is all that skill actually is. So here I've got 4 examples. The first example is a metal and a nonmetal. See, Na is my metal, and I know it's got a charge of +1. Cl is a nonmetal, and I know it has a charge of -1. So what I'm going to do is I'm going to go to the periodic table and locate Na on the periodic table, and I'm going to find its name, and its name is sodium. And then I'm going to locate Cl on the periodic table and find its name, and I'm going to write down its name, which is chlorine. And then because this is an ionic compound, I'm going to drop the INE and change it to IDE. So the final actual name for this compound is sodium chloride. Here's another example. Al, I know that to be a metal on the periodic table. I know it's charged to be a +3. S, I know that to be a nonmetal. I know it's charged to be a -2. So I locate Al on the periodic table, and I see that it's aluminum. So I write that down. I locate S on the periodic table, and I see that it's sulfur. And I write that down. And then I'm going to change the UR to IDE. So my new name is going to be aluminum sulfide. Okay, so now I want to take a second or two and have you give MgF2 a shot. So go ahead and give MgF2 a shot, and then I'll come back and I'll work through that with you. All right, looks like a bunch of you have given that a shot, or at least have started to give it a shot, so here we go. Mg, I know is a metal, and I know its charge is a +2. F is a metal, or is a nonmetal, and I know its charge is a -1. I locate Mg on the periodic table, and I see that its name is magnesium. I locate F on the periodic table, and I see that its name is fluorine. And I'm going to drop the INE and add IDE, and my new name becomes magnesium fluoride. And I'm hoping you got that as well. Next one is a little tricky, and not tricky hard, but just a little bit trickier in terms of the name itself. So Na is a metal, and I know that it's got a charge of +1 because of its location on the periodic table. P is a nonmetal, and I know its charge is a -3 because of its location on the periodic table. I locate Na, and I find on the periodic table, and I find that its name is sodium. And I locate P on the periodic table, and I find out that its name is phosphorus. Oops. That's not even close. pH phos. PHOROUS. Wow. And I'm going to drop the OROUS and put IDE. And so then I'm going to rewrite my name to be sodium phosphide. Wow, did I butcher that? Yeah, all right, that's better. Now, some of you might be thinking to yourselves, like, well, how do you know where to drop this stuff? Like, couldn't you have just dropped the OUS and put phosphoride? Yeah, you could have. I'm not going to take off on that. What I'm looking for you to do is to be able to tell me that you needed to add IDE when you needed to add IDE. So as long as it's reasonably close, I'm good with that. Any questions here? All right. The next thing that we're going to move on to is writing ionic compound formulas. Here the rules are pretty simple. You take the ions, symbols, and their charge. You drop the charge symbols, the plus and the minus, crisscross the numbers down, and reduce if possible. So I'm going to take that last example from up above, and I'm going to work through that. So in the last example, we said that it was sodium, so that was Na with a +1 charge, and it was phosphorus, phosphide, with a -3 charge. So what happens is that we take the plus and the minus away, and they just become numbers, and we drop that 1 down right here. We crisscross it down behind the P. We take that 3 and we crisscross it down behind the Na. And when we rewrite it, we get Na3P1. And then I'm going to look at my ratio here. And my ratio is really the relationship between Na and P. So in this instance, I have 3 Nas for every 1 P. I can't simplify that ratio anymore. So I'm going to rewrite my answer to be Na 3P. In chemistry, we avoid writing ones if possible, so that's the best possible answer. So now we're going to go ahead and go through a couple more examples just like this. And hopefully you'll find this to be not too difficult today. So we have calcium sulfide. All right, first of all, I know that calcium is my metal, and I know that calcium has a charge of +2. Sulfide is my nonmetal in this case, and it has a charge of -2. So the first thing I'm going to do is I'm going to go to the periodic table, and I'm going to find the symbol for calcium. And I see that calcium symbol is a Ca +2, and the sulfide symbol is S -2. The next thing I'm going to do is crisscross my charges down. So the 2 from the calcium is going to go behind the S, and the 2 from the S is going to go behind the calcium. And I'm going to clean this up and rewrite it. So I'm going to get Ca2S2. Then I'm going to check my ratio, and I see that the ratio is 2 calciums for every 2 sulfur. And that I can simplify to 1:1. So I'm going to have a 1:1 ratio. So I'm going to rewrite my formula to be Ca1S1. And in chemistry, we try to avoid writing ones if possible, so I'm going to clean that up even further and simply write CaS. And that will be my final answer that I report. Any questions about this? All right, let's do another. So here I have lithium and oxide. So I know that lithium is a metal, and I know its charge is +1. I know oxide is a nonmetal, and its charge is -2. Oops, -2. So I'm going to write those ions next to each other, Li +1 and O -2. I'm going to crisscross my charges down. So the 1 goes behind the oxygen, and the 2 goes behind the lithium. And then I'm going to rewrite my formula with that new knowledge. So Li2O1. So now I'm going to consult and check my ratio. So the ratio of lithium to oxygen is 2 lithiums for every 1 oxygen. Now I can't simplify that ratio, so I'm going to rewrite this to be as is, and I'm just going to drop that 1. So it's going to be Li2O. And that's going to be my answer. Now, I'm going to have you guys give magnesium phosphide a try. So, ready, set, try magnesium phosphide, please. Okay, so hopefully you identified magnesium as your metal, and it had a +2 charge. And you identified phosphide as your nonmetal, and it had a -3 charge. So I found magnesium symbol, which is Mg, it's +2. Phosphide symbol, which is P, -3. We crisscross the charges down. Oops. And we rewrote the formula. So Mg3P2. Now I'm going to check my ratio. The ratio is 3 magnesiums for every 2 phosphoruses. So I can't really simplify that. So my final answer is going to be Mg3P2. And I throw it in a box like so. Last one, potassium is your metal, which is +1. Fluoride is your nonmetal, which is -1. We're going to set the charges, the symbols of the charges next to each other. So potassium is a +1. Fluoride is a -1. I'm going to crisscross the charges down and rewrite. So here I have potassium 1, F1. I'm going to check my ratio. And it's 1-to-1. I can't really simplify that anymore, so I'm going to rewrite this by dropping the ones because we don't use those in chemistry if we can avoid it. So your final answer just becomes KF, like that. Okay, so in this instance, there's actually more that I kind of wanted to cover today, but I don't have enough time to do it justice, so I'm not going to push through. That seems like a terrible idea. Now, so we will pick the rest of this lesson up tomorrow. But are there any questions about this particular lesson before we talk about homework? Okay. All right. So we're going to wrap this up here, and then we'll talk about